Okay, today I'm going to teach you derivative of logarithm functions. So the first one is the natural log, because we know we have the natural log and other log, that's the logarithm to other base. So we normally write natural log as log to base e, or if you don't write it that way, we'll write it as len fx. So len, we know that log e could be written as len. So whenever you see log to base e, it means len. That's logarithmus naturalis. That's the Latin name. So whenever we're asked to differentiate the natural logarithm, the derivative is very easy. Just differentiate the function, which is f prime, over the original function, which is fx. Yes. So example, if someone asks you to find the derivative of len x, without wasting time, the answer is 1 over x. Or maybe if someone asks you to differentiate len x squared plus 2x plus 5, the answer is simple. We differentiate this, which is 2x plus 2, over the original function, which is x squared plus 2x plus 5. Do you see? It is very easy. So again, what if is not natural log? So, okay, maybe if you are given log to any base, where a is any base, could be 2, 3, 4, 5, any base. So what do? It's very easy. We use our change of base law. Do you remember in logarithm? Okay, from our change of base law, assuming you want to change, we are given the original log base a to be, we want to change it to another base, maybe base c. It's very simple. You introduce your new base in both numerator and denominator. You now put the numbers. So see, we've changed this from base a to base c. So since I have base a here, I want it to be in base e. So I have log e now of fx over log e of a, which could be written as len fx over len a. Yes, they're the same. So I'm going to use that property now to solve. So instead of, if I'm now asked to find the derivative of log base a of fx, is the same thing as the derivative of len fx over len a. Remember, a is a constant. I told you it could be any number greater than 1. A must be a number greater than 1 from law of logarithm. So we're on this now. So let me write it here. So the derivative of len fx over len a. And we know that the derivative, to find the derivative, we can bring out the constant, which is 1 over len a is the constant. So this is a number, is a constant, a is a constant, times derivative of len fx. And from what we've done before, the derivative of len fx is now f prime x over fx. So that's the derivative of any other base except the natural. For example, if someone asks you to find the derivative of, someone asks you to evaluate the derivative of maybe log 5x. Without wasting time, I told you the answer is 1 from this. 1 over len 5. We now differentiate this, which is 1 over the original. So the answer is 1 over x len 5 from what we have just explained here. Our a here is 5, so 1 over ln 5. If you differentiate x, you have 1. If you differentiate x, you have 1 over the original, as you can see. Our fx is x, so f prime x is 1 over x, so that's it. Okay, let's now solve questions that are very technical. Assuming we're asked to find the derivative of this function. Find the derivative of that. So it's very easy. Let's start with the first one. So we're given this. So what do you do? From what I did is base a. So we have that the derivative of log to base 5 of x squared plus 3x minus 5 is now, remember what I did, 1 over ln 5. We now differentiate f prime x. If you differentiate this, is 2x plus 3 over the original, which is x squared plus 3x minus 5. So maybe we'll write it as 2x plus 3 over x squared plus 3x minus 5 ln 5. So that's the answer. So the first one is easy, but look at this second one. Okay, look at the second one. We have to do we have to simplify this so that it will be easy for us to solve. Do you remember our laws of logarithm? The laws of logarithm states that if you have log maybe log a b c is the same as c log a b. Do you remember from the law? So I'm going to use it here because I can write this as ln. This is 7x plus 10 over 4x squared minus 3x minus 5 all raised to the power of 8 over 3. Do you remember? From this, just from indices, that if you have a is the same as a y over x. So that's what I used here. So next thing, we'll now apply the laws of logarithm, because as you can see, that's it. So this we can write this as 8 over 3 ln 7x plus 10 over 4x squared minus 3x minus 5. So the two are the same. So let's now find the derivative. Therefore, the derivative of what we are asked to find, which is the derivative of ln cube root of 7x plus 10 over 4x squared minus 3x minus all raised to power of 8 is now the same as the derivative of 8 over 3 ln 7x plus 10 over 4x squared minus 3x minus 5. So which could be written as 8 over 3, because this is a constant, so we can bring the constant 8 over 3 derivative of ln 7x plus 10 over 4x squared minus 3x minus 5. Again, do you remember the laws of logarithm that states that if you have log ab minus log, that if you notice the bases are the same and you have to subtract, you can bring the two together as log ab over c. So as you can see, we can now split this as this 8 over 3, the derivative of ln 7x plus 10 minus ln 4x squared minus 3x minus 5. so which is the same as 8 over 3. We now differentiate. This is now like what we've done now. So our fx is 7x plus 10. So which is, if you differentiate 7x plus 10, we have 7 over the original, which is 7x plus 10 minus, we differentiate this, which is 8x minus 3 over the original, which is 4x squared minus 3x minus 5. So that's our answer. That's the derivative. So do you see the question is very tricky? It's very tricky. So let's solve the final one. Let's finish up. Let's solve the last one. As you can see, we are given this, but though in the formal question, I just arranged it so that you can see. I wrote sine x first, but let's write this first so that we can easily see what will happen. To solve this, what I will do, I will say let's fx be this function, everything 1 minus x squared sine x over 2x cubed plus 2x plus 5. So what do? We introduce log to both sides. So let's introduce log to both sides. So introducing log to both sides, natural log ln to both sides. So we now see that ln fx is the same as ln everything here, which is square root 1 minus x squared sine x over 2x cubed plus 2x plus 5. So what do? We now differentiate both sides. So we now differentiate both sides, or differentiate both sides. So which is now f. If you differentiate the left hand side, I have f prime x over fx. We now differentiate this. But before this, we can easily see that this, we can write this as ln, this product ln 1 minus x squared, this product, so plus ln sine x minus ln 2x cubed plus 2x plus 5. Do you remember the law of logarithm, that if you have log AB plus log AC, once they have the same base, you just bring the two together, B times C. But if it's minus, it's now B over C. So that was what I used here. We have products, so I splitted it to be addition, and finally division, which is minus. So we now differentiate this, though we can still write this as, from the law that says that if log A, B, C, that you can write it as C log A, B. So because square roots, this square root is raised to power half. So we can write it as half ln 1 minus x squared. Because square root is raised to power half plus ln sine x, finally minus ln 2x cubed plus 2x plus 5. So let's differentiate this now. I've done the, I just simplify this further so that I can be able to differentiate it faster. So if we differentiate this, it's very simple. This is half. The derivative of this is minus 2x over 1 minus x squared. Do you remember? Differentiate this out. Differentiate the inner one, which is minus 2x over the original. So that's for this one. Plus, if I differentiate sine, is cos over the original, which is sine. Minus, if I differentiate this, I have 6x squared plus 2 over the original, which is 2x cubed plus 2x plus 5. So we are still solving. So that's what we have. We'll continue. Remember, our main aim is to differentiate this, which is to find f prime x. So we are going to make f prime x the subject of formula here. So making it the subject of formula, we have that f prime x is now the product that you cross multiply. You have all this. Okay, we can reduce this as this. So okay, let's reduce it. So this we have. So we can still write this as x over x squared minus 1. Do you get? What I did is 2 remaining minus. So that minus will come down. So 2 times this. So I now have x squared minus, so that we'll remove the negative sign entirely. Plus cos x over sine x is cot x. Do you remember our trigonometry? Minus 6x squared plus 2 over 2x cubed plus 2x plus 5 times fx. Do you get? I cross multiplied. So fx will multiply all this. Then I simplified further to have this. So we'll remember, you write this is x over x squared minus 1 plus cot x minus 6x squared plus 2 over 2x cubed plus 2x plus 5. Do you remember the value fx? Fx is the original function, which is this. It's the original function. Maybe let me just copy it. That's it. Okay, maybe let me just write. So I have square roots 1 minus sine 1 minus x squared sine x over 2x cubed plus 2x plus 5. So that's our answer. So that's our answer.